Thanks for coming to our talk on MLeap, and also I want to thank the organizers for putting everything together. My name is Holland Wilkins. I'm a co-founder at Combust, which is a company that I started with Mikhail about a year ago. And we also started working on this project called MLeap about a year and a half ago.
I'm Mikhail Semenek, as Holland mentioned, co-founder of Combust, also a co-creator of MLeap, which is an open source technology that allows you to take your Spark-trained machine learning pipelines and models and execute them in a low latency prediction service. So on our talk, we're really going to have three parts. First, we'll tell you a little bit more about what MLeap is, kind of what problems it's trying to solve. We'll do a deep dive into the architecture and how it's really put together. We'll give you some examples of how some companies are using it in a production environment. We'll cover the MLeap product roadmap for those of you that have been following the project and kind of want to know where we're taking it next. And then we'll finish off with a demo where we'll show you how to train a machine learning pipeline in Spark, and then also deploy it in a streaming environment where we're training online learning models and then deploying those regularly to low latency prediction service. So why MLeap? So when Holland and I started working together at a company like 3 or 4 years ago, we essentially had a problem I think a lot of people face, is that it takes way too long to get machine learning models out into production. So we've been on projects where it's taken months. We've even been on a project where it literally took a year to get a model out into production. And for us, I think, and for others, it's unacceptable. We believe this can be done instantly. So that's when we started MLeap with essentially a set of criteria for the design. The biggest thing is that it had to eliminate any and all recoding of the machine learning pipelines that your data scientists, researchers, or machine learning engineers put together in order to get it into production. So zero rewriting of code. The second requirement is that the serving and inference system had to be very low latency. So, I mean, as we'll show you some charts, essentially like sub 10 milliseconds, sub 20 millisecond response times. The other big requirement is that there should be minimal amount of new code that a researcher or a data scientist has to write to implement any custom transformers or any custom logic. And also this should be a very lightweight library with a minimal set of dependencies and other technologies so that users can choose how and where they integrate it into their system. So that's where we started off about a year ago. And now, if you go to MLeap, you'll find a couple of other things in there. So the biggest thing is for inference is that we've essentially made it a requirement so that prediction has to happen outside the JVM. You should be able to take your Spark-trained models and deploy them on the edge. So meaning IoT devices, your phones, Raspberry Pis, drones, et cetera. And then it should also support other machine learning frameworks like Scikitlearn and Tensorflow, because obviously not everybody does training in Spark. So to give you a high-level overview of how we think about this in MLeap, so there are really two components, and we'll go into details. There's MLeap bundles, and an MLeap bundle is a serialization framework for the entire machine learning pipeline, which includes all of your feature transformers, as well as your models, so like your linear regressions, random forest, neural nets. And the motivation behind that is the math that gets executed by a standard scaler trained in Spark and a standard scaler that gets trained in Scikit or TensorFlow is exactly the same. And same goes for like regressions and any other transformers you may have. So let's come up with a common serialization framework for those technologies, and then also build out a second component, which is the execution engine that knows how to ingest these MLeap bundles and execute the pipelines that you've trained during research. So one last thing a couple of things I want to say is the first thing that we always try to tell people is that when you use MLeap, you don't have to change anything about how you write your machine learning pipelines today. So like if you're integrating MLeap, you're going to continue to write your vanilla Spark ML pipelines. The two things that we're providing you with MLeap are two tools. The first tool is to serialize your machine learning pipeline. And again, this is both your feature pipeline and your model. And the second tool is an execution engine to execute your pipelines that are not dependent on Spark and the Spark context. So to go into the MLeap bundle, the serialization framework, just a little bit of motivation for that. So like, let's say you have a very simplistic machine learning pipeline where you're standard scaling your continuous features, your string indexing, and one-hot encoding your categorical features. You're assembling them, and you're running a linear regression, right? Like, so we can take that entire pipeline, serialize it, and deploy it. But then let's say, a month later, your researcher, data scientist says like, well, okay, if we had principal component analysis and we switch from a linear regression to a random forest model, like we get, much better performance. When they make that change, if you're supporting these models or if you're on the production side, there's zero new code that you have to write. They can just make that change to their pipeline, and they can still continue to deploy it to MLeap serving, again, without any additional work. So at this point, I'll hand it over to Holland, who will go over like the details of MLeap bundles.
Yeah. So just to sort of take a look at what these things actually look like, they're a zip file, and they contain a set of JSON and protobuf files inside of them. And the reason that we use JSON and protobuf is because most programmers are familiar with those technologies. Pretty much every single programming language supports them. They're pretty portable. And the reason that we put everything into a zip file is because we want your entire pipeline to be self-contained. So you can literally just take a pipeline that you've trained, email it to your coworker, and they can start transforming with it immediately, pretty much. If you look inside of the zip file, you'll find this thing called bundle.json, which is just some high-level metadata about your pipeline, like the name of it, when it was created, what serialization version we're using, stuff like that. Then the other two files that you'll see a lot of are this model.json and node.json file. And you'll see one of each of those for each transformer within your pipeline. The model JSON file has all of your coefficients, your intercepts, decision trees for random forest models, string lookups for your string indexers, array sizes for one-hot encoders, all that sort of stuff. The node JSON file is what actually wires that model into your data frame. So it says, these are my input columns for the linear regression, and this is my output column for the linear regression, sort of stuff like that. One of the goals that we have with BundleML and MLeap in general, because we get a lot of requests for it, is custom transformers. So we've tried to make this process as simple as possible. Pretty much you implement the logic for your transformer once, and you share it between an MLeap transformer and a Spark transformer. Once you've built your MLeap transformer, Spark transformer, all of your logic, then you build the serializers for both of those transformers, so you can actually take it and put it into an MLeap bundle. So there's sort of 5 different pieces of code that you have to write to get this working, but they're all relatively small pieces.
Yeah, I think one thing to mention there is that we have near complete coverage of all of the Spark transformers that exist in ML pipelines today.
Mm-hmm. Yeah, so this is only if you need something outside of what Spark provides already.
Yep.
I've talked about like data frame and sort of like hooking data up to your models. We use this thing called a leap frame, which if you know what a Spark data frame is, you know essentially what a leap frame is. It's just a lightweight version of that Spark data frame. It has a schema that defines all of your column values, and it has row data that defines all of the data within your leap frame. So that's what I'm talking about when I say leap frame. MLeap serving is something that we introduced about 2 months ago, I'd say. And what it does is it takes these MLeap bundles, loads them up into an API server. You can start making RESTful JSON calls against it in order to start actually executing your pipeline. So the process is you train your model in Spark, you train your model in Scikitlearn or Tensorflow, export this MLeap bundle, and then load it up into the MLeap serving module that's going to then build a RESTful API service out of it for you. Again, Scikitlearn integration works very similar to Spark. You take your transformer pipeline that you've built in Scikitlearn, export it to an MLeap bundle, run it in the same exact runtime that you'd be executing your Spark pipeline in. We have about 50% support for the scikit-learn transformers right now, and we're actually going to be working towards 100% support for that moving forward. Just briefly, TensorFlow integration is a little bit differently, it works a little bit differently than Spark and scikit-learn integration. For TensorFlow, we actually implement it as a custom transformer that sort of takes all the data in the Leap frame, converts it into TensorFlow data, and then uses the JNI to execute your TensorFlow graph. The cool thing about this is that you can sort of piece together pieces of your pipeline you've built in Spark, and then maybe you want to put a neural network that you've trained in TensorFlow into your pipeline somehow. So you can piece all these different technologies together. Benchmarks. MLeap is really fast. So that pipeline that we were showing you earlier with the random forest, the string indexing, the one-hot encoding, all that, it executes in about 23 microseconds after you have it loaded into memory. And actually, we can optimize it even further and get it executing in about 7 microseconds if you take away all the overhead of all of your schema transformations. This is a real, actual production example of the kind of performance you can expect with MLeap. So there was a company that we were working with that had their Spark pipelines deployed using a local Spark context, local Spark data frame, and they were getting roughly 200 millisecond to 1 second response times, which is pretty bad for an API service if you're making one-off requests to it. When they deployed the pipeline with Spark, they started getting 4 to 15 millisecond response times, which is a huge increase in speed, obviously.
Sorry, when they deployed it with MLeap.
So deployed with deployed with MLeap, sorry. They got a huge speed increase. And I want to mention the reason that it's 4 to 15 milliseconds instead of those 7 or 23 nanoseconds I was talking about before, or microseconds that I was talking about before, is because there's a lot of HTTP overhead and serialization overhead when you're actually executing this in production. Where's MLeap going? We have close to 100% support for MLeap Spark. We're working on scikit integration, but really the two things I want to point out here are we're working towards fully typed transformer pipelines so that we can perform a lot of optimizations on your pipeline. So if we know the data types of all the inputs, we know the data types that all your models are expecting, there's a lot of optimization we can do there to make them run really fast. MLeap Rust, we're trying to build this thing that takes your pipelines and runs a JIT on it and actually produces very fast executable code. And you'll get all the same benefits that you would get using MLeap JVM. So Rust is really cool because we can sort of take advantage of hardware. So instead of just using the CPU to execute all of these transformations, we can start using CUDA and HIP and OpenCL. We can also build different language bindings. So you can train your model in Spark, and then you can export it to an MLeap bundle. Then you can start running it on iPhones. You can start running it on Raspberry Pis. If in production you use Ruby, you can start transforming data from Ruby.
Okay, so we're going to go into the demo portion. I'm just going to talk a little bit about what we're going to do. So we're going to have a data set of apartment housing listing data. And first what we're going to do is we're going to train a Spark pipeline that just has the feature transformers. So go from raw data to standard scalars, one-hot encoders. We're going to serialize that pipeline into a bundle ML file. And then we're also going to spin up 2 streaming jobs. And I'll explain in a second why 2. The first one is going to do your feature transformation, and then it's going to stream your raw data that's been transformed using your feature transformers to another streaming job that's actually going to be training your online learning model, in which case it's going to be a linear regression. And then after a specific time interval, we're going to serialize the online linear model to a bundle file. We're going to combine it with your serialized feature transformer pipeline, and we're going to deploy them essentially, I think, every 15 seconds as a new model gets developed. We're going to deploy it to an instance of MLeap serving, so you can kind of see if you need a way to, serialize your online models and deploy them regularly, you can do it with MLeap. And the reason why there are two streaming steps is because Spark right now doesn't have like streaming versions of like one-hot encoders or standard scalars, so we kind of have to have this two-piece pipeline. By the way, all of these demos are available on our GitHub page if you just look for MLeap demos. And there we not only have, wait, how do I find the?
Oh yeah, just right here.
Okay, and there we don't only just have the streaming stuff, we also have the original pipeline if you were to train the entire thing in batch. And if you just, yeah, if you were running, like, I don't know, training models like once a week or something and you wanted to export those. So pretty much all of this is just vanilla Spark, like you're pretty much just importing all of your Spark transformers. You're reading your data. For us, we're just reading it from just a local CSV file or the local Abro file. We're doing some basic data transformations and just some basic computation using SQL. Showing you a little bit of statistics, like for example, which cities have the highest number of listings, as well as which cities have the highest number of or highest average price per listing, which is not too surprising that it's beach cities. And then here, this is really where you're starting to build out your Spark pipeline. So we're defining our continuous features, our categorical features. We're getting rid of all the nulls in the data. We're splitting it into training validation. All this should be very familiar, fairly basic stuff. Defining our continuous feature pipeline, which is really a vector assembler and a standard scalar. But again, you can piece together any transformer in Spark, or if you have custom transformers. We define our categorical feature pipeline. And then we assemble them together, our continuous and categorical pipelines. Here we actually, for the demo that we have, like if you're just training these models in batch, we actually show like you can train your random forest model, you can train your linear regression, and you can export all of those to bundle ML as well. But for us, we're actually just going to stop here, where we're just taking the Spark feature pipeline, and we're just serializing that portion to a bundle, because we're going to show you how to load that into a streaming job just to transform your raw data. But the demo online, if you go on our GitHub page, it has a lot of examples of like how to serialize the models as well, and how to load them up into MLeap serving and a bunch of other functionality that MLeap has.
Yeah, so let's actually take a look at this file here. So this is an actual MLeap bundle here. This is our feature pipeline. You can see
it a little bigger.
Oh.
Yeah.
We have our string indexers. We have our one-hot encoders. Let's take a look at like what a standard scalar looks like. Maybe as you would expect, there's a mean, there's a standard deviation for all of the features that it's scaling. That's the model.json that I was talking about earlier. And then in the node.json, it's actually telling you which column is your input. In this case, we call it unscaled continuous features. And which column is your output. In this case, we call it scaled continuous features. So those are what the MLeap bundles look like. Now I'm actually just going to start up an MLeap serving instance over here. And this is the, excuse me, this is the actual API service that takes in those MLeap bundles and lets you put JSON data into it, and it'll execute the transformer pipeline against it, and it will give you the results of it.
And by the way, it's available as both source code on the GitHub page and also a Docker container, and there's also instructions on the GitHub page of like how to essentially run all these steps that Holland's running right now.
Yep. Before I start this up, I just want to go through the feature transforming piece of this. So we're going to start up our first job, which is streaming in CSV data, transforming it into a set of labeled points that we're then going to output, and another job is going to take those labeled points in and train our online linear regression. So here we're just setting up a Spark session, we're creating the server socket, we're loading up all the data like I was talking about, and then we're using Spark streaming to actually read in all of the row data, transform it using our feature pipeline, and output this set of labeled points. So I'm going to go ahead, I'll start that up now. takes about 10 seconds to start up here. And we see it here, it's waiting for a connection from a client. Our client is actually the thing that's going to be training the online linear regression. And the code for that looks like this. So we start up a Spark session, load up our feature transformer pipeline, build a streaming context, connect it to that server that we just spun up, start up our streaming linear regression, and then I have this background thread that's running. And every 15 seconds, what it's doing is it's taking the latest results from that streaming linear regression, and it's outputting our entire feature pipeline along with that linear regression, and then it's loading it into MLeap serving so that we can start using it to get results. So.
Yeah, and in real life, you're probably not going to be deploying models every 15 seconds, but just because we have a short amount of time, we're just going to do that for the demonstration.
Yep. So over here, our streaming job has started, and I'm going to watch for when we actually get a new model in. So this is the folder that I'm saving my models to, and every 15 seconds, it's going to put something new in there. So we just got the latest model. I'm going to actually use some test data that I have prepared to actually execute my model. And right now, because training hasn't gone on for long enough, we're predicting that I should be renting my Airbnb out for $0, which obviously is not correct. But we see that I have a second model produced here. So now if I transform again, we actually see it saying, oh, it should be $101 a night. So our model is getting a little bit better. We have a little bit more training data that we've streamed on. I have a third model now. Guess it didn't change. Oh, there we go. So now it's saying it should be $113 a night. So this is sort of cool, because what we do is we're streaming all of this data, and we're producing models on the fly, and we can actually deploy them into production as the model gets better because it's had more data to train off of. So again, go take a look at this online. Pretty cool demo. I'm just going to stop all this here. Last thing I want to talk about is we're trying to grow the community right now. So about a year ago, it was just Mikhail and I working on this. Since then, we've had 12 other people contribute to the project. We're looking for a product manager for MLeap so that we can grow our products and make them as good as possible. And we also want people to start writing blog posts about their use cases with it, their success stories. So we're reaching out to everyone who's sort of been involved in this process and asking them to help us with promoting MLeap.
Yep.
That's it. Thank you, guys.
Yeah, thanks, everyone. Yeah, I guess we'll take questions if you guys have any, or feel free to stop by or reach out, like either like on our emails are up there, or like on Twitter or Getter. Cool.
All right, cool.
Thanks.
Thank you.
Oh, go ahead.
Are you talking about the ALS model? Yeah, so actually we're working with a company right now who wants to implement it, and so that's one of the few Spark transformers we don't support right now, but we're working on it.
Cool. Thanks, guys. Oh, all right.
What about other models, like you talked about Tensorflow, about the Terra, the cafe, or the other type?
So we don't have those integrations right now, but there's no reason that we couldn't build, sort of integrate it the same way we did with TensorFlow.
All right. Thank you.
Thanks.